Alright, so today's lesson is on division of segments and angles. This is 1.5 in your books. And this lesson is dedicated to my 6-hour class who says that I am too monotone on here. So let's spice it up a little bit, shall we? Our objectives for today. 1. Identify midpoints and bisectors of segments. 2. Identify trisection points and trisectors of segments. Identify angle bisectors, which is number 3. And finally, coming in at number 4, identify angle trisectors. And that's it. Alright, so here we have a segment, AB. And we're going to be starting off with midpoints and bisectors of segments. So, definition. Remember, these definitions are what you're going to be using in your proofs. So make sure that you know them. A point or segment, ray or line, that divides a segment into two congruent segments. Bisects the segment. Notice it's in red, so that's important. The bisection is called the midpoint of the segment. Again, in red, so it's important. So what do I mean by that? Well, first off, let's cover a few ground rules. Only segments can have midpoints. Why do you think a ray or line can't have a midpoint? I'll ask you that tomorrow in class. Save your answers for later. In the example below, how many midpoints could there be? How many bisectors could there be? Well, it's a segment, so we know it can have a midpoint. And we also know that there is probably going to be only one point that divides it evenly, right? Because if there was more than one, it wouldn't be dividing it evenly. So there's one point, one midpoint. However, this could be a bisector. Pardon my screwed up line. This could be a bisector. This could be a bisector. Make that into a really big arrow. My point is that you could have an infinite amount of lines that could be bisectors, but there's only one point that could be a midpoint. So remember that. Doesn't have to go like exactly with it. Okay, moving right along, if it lets me. There we go. So in this example, if segment XY bisects segment AC at B, what conclusions can we draw? Well, first of all, I guess it would help if you knew where A and B is. So here's A, here's B. I'm guessing when I move this that it's going to click over. But in the meantime, let's cover this. So again, there's only one midpoint, right? And XY bisects AC at B. So that means that it bisects at the midpoint of A and C. So what conclusions can we draw? Well, we know that B is the midpoint of segment AC. And there we go. Let me get rid of that so it's less confusing. And we also know that because it's the midpoint, that AB, which is this piece right here, is the same length as BC by definition of midpoint. Remember, it's exactly in between. So segment AB and segment BC are congruent. Okay, let's move along to trisection points and trisecting a segment. Again, definition. 2 points or segments, rays, or lines that divide a segment into 3 congruent segments. Trisect the segment. Notice trisect. 3. Means there's 3 congruent segments. The 2 points at which the segment is divided are called the trisection points of the segment. So, with a bisector, there's 1 point and 2 congruent parts. With a trisector, there's 3 points or lines or rays or whatever. And so 2 points and 3 congruent parts. Again, only segments can have trisection points. Okay, so if E and F are trisection points of segment DG, what conclusions can we draw? Well, we can say that DE is congruent to EF, is congruent to FG, because we said that E and F are trisection points, since that was your given. We also know that segment HE and segment HF are trisectors of segment DG. So again, a few things that we can draw from just being given a little bit of information. Alright, now let's look at angle bisectors. Ignore the part at the bottom for a second. Definition. We have a lot of definitions this time around. A ray that divides an angle into two congruent angles bisects the angle. The dividing ray is called the bisector of the angle. So here we have angle ABC, and it's being bisected by angle BD. So this is the dividing ray or the bisector. So if angle ABD, that's this right here, is congruent to DBC, then ray BD, not DB, BD, not DB. Remember, with rays you always state the endpoint or the starting point first, and then the direction, the second letter is the direction it's going. So that would be the bisector of this. So what you would be able to do if this was a diagram later on, you could say, okay, this is congruent to this. So remember, we can use these lines to show congruence of angles. Okay, if there was more angles, and let's say these were the second angles, you could do that. Put a tick mark through them. Anything to show that these two angles are congruent. Okay? Now, angle trisectors work much the same way. A ray that divides an angle into two congruent angles bisects the angle. The dividing ray is called the bisector of the angle. Okay, so that was bisects. So now we've got if angle ABC is congruent to angle CBD is congruent to DBE, then ray BC and BD trisect angle ABE. So this should actually be 3, and this should be trisects, and called the trisector. Okay, my bad. At any rate, you get the point. It works a lot of the same ways that segments do. Okay, 3 equal angles as opposed to 3 equal segments when we're talking about segment trisectors. Okay. Finally, practice problem. Okay, so we have this figure here. We are given that ray AD, so starting at A and going down to D, bisects angle BAC and segment BC. What parts of triangle ABC are congruent? Well, let's think about our definitions. Let's start with the segments. This says that AD bisects BC. So if it bisects this, then we can determine that D is the midpoint of segment BC. We can also determine that BD and DC are congruent, or if you want the shorthand version, BD is congruent to DC. Okay, and that's about all we can say about the segments. Now, let's look at the angles. Well, since this bisects the angle, we also know that this and this are congruent. So we can also say that angle BAD or DAB, but remember, since A is the vertex, we need to have that be in the middle, is congruent to angle DAC or CAD, whichever you prefer. And the reason for that is because it says we are given that angle, or that ray AD bisects BAC. So that would be about it that you could find for congruent parts. Even though it looks like we could say, oh well, wait, what about these? These look congruent. Yeah, well, we weren't told what these angles are. So even though this looks like a nice equilateral triangle that we could say, oh well, this is equal to this, and this angle is equal. I could draw a figure here where D would still bisect BC, but it wouldn't look that way. So I'm just saying, don't assume anything unless it's given. Okay, that's your video for today. Hopefully it wasn't too monotone for you. You guys have a lovely evening, and I look forward to seeing your smiling faces tomorrow in class. Have a great night.